All right, so I'm going to start with question 1. It says to solve each proportion. I'm going to snip that into the workspace, and I hope you can see my workspace. It says 2
Yes.
over 5 equals x over 25. Great. A lot of ways to solve this. The most common way is to cross multiply. Hopefully you saw that in class. Do you know what I
Yeah.
mean by that?
Multiply the 2 times 25 and the
Yep,
x times 5.
that's right. Um, and you can multiply them out, and then you just divide both sides by 5, in this case, to get x equals 10.
Okay.
That one's, pretty straightforward.
Yeah.
Let's try number 2. Snip that in here. All right, so we got same thing here. 10 times x equals 7 times 3, so 10x equals 21. Divide both sides by 10, so x equals 2.1, or 21 divided by 10. Either of those would be okay in this case. If there's anything that's unclear, again, just try to let me know, and I'll provide more explanation as needed. As a reminder, I'll send you the notes at the end, and then the recording pretty quickly afterwards.
Okay,
Th-
thank you.
this problem, when you cross multiply, you have to remember that the numerators are in implied parentheses, and when you write it the way I'm doing with the implied parentheses, it makes it clear, okay, I've got to distribute the 9, distribute the 11 to both terms. That's 9y plus 36 equals 11y minus 22. So we're gonna solve for y here, which means we got to move some things around. I'm gonna subtract 9y from both sides. So that gives us 36 equals 2y minus 22. And then add 22 to both sides. 58 equals 2y, divide by 2, divide by 2, so y equals 29. I suppose you could check this, but it's not necessary, unless you were unsure of the work you'd done up to this point. Um, okay, this one, again, there's kind of implied parentheses. Whenever you have more than one term in the top or bottom, you can assume there's implied parentheses around it. So this is z minus 1 times z plus 1 equals 3 times 8. So here on the left, when you FOIL this, you're going to FOIL this on the left. Hopefully you remember how to do that. It's first add or enter last. You end up getting z squared minus z plus z minus 1, or z squared minus 1 equals 24. You move that 1 over, you add 1 to both sides, so z squared equals 25. When you take the square root, it's plus or minus the square root of 25, which is z equals plus or minus 5. Any follow up from that, or anything that's unclear from that we need to do? Or is it okay to move on to 5?
I think we're good.
Okay. 5 is the story problem or word problem. That's probably setting up some sort of proportion, because that's what you did in the first 4 problems. So we'll assume that's the case. A pitcher's earned run average, or ERA, is the product of 9 and the ratio of earned runs the pitcher has allowed to the number of innings pitched. During the 2007 season, Johan Santana of the Minnesota Twins allowed 81 earned runs, 219 innings. Find his ERA. All right, so it says the ERA is the product of 9. So 9 and the ratio of earned runs, the earned runs here is 219 to the number of innings pitched. I'm sorry. I'm sorry. I wrote this backwards. Let me get rid of that. It was 81 earned runs, 219 innings pitched. So I suppose it's just a really complicated way of telling you to multiply these numbers and divide these numbers. If you have a calculator handy, go ahead and try the calculation. And you should get this value.
Wait, did you multiply 9 times 81 and then divide it by 219?
Yes.
Oh, okay.
So I wrote the formula at the top right. I mean, I don't think you're going to get this problem unless your instructor's been doing that, but could be helpful if you see it again. Okay, moving on to 6. Find each pair of polygons is similar. So they're telling you that they are similar. That's really helpful because the ratio of the sides is in a proportion. So sometimes the words just don't do that justice. It's like saying if AB is similar to PQ, then we can put those numbers in there's 1, 2, 3, 4 spaces. What my preference is always put the thing that we're trying to find, in this case X, in the top left. I mean, that's just my preference. So that's here. Okay. So the corresponding thing is this 10 over here side. It's like saying PR and AC is here. So then we've got to grab another, numbers. And I'll just arbitrarily pick 9 to go top right because this is for the that side here, and then 4 down here on the bottom.
Okay.
Is that clear?
Kind of.
Okay. So let's just say we said X to 10 again, like we did X and 10. You could choose 18 and 8. 18 and 8 go together. 9 and 4 go together. X and 10 go together.
Okay.
So once you write the proportion, you can solve it. So I'd like you to solve the one on the left. I'm going to solve the one on the right, and you're going to see that we're going to get the same thing when we're all done.
I got 22.5.
Me too. Okay, so let me give just a little more information because I don't think I did a great job of doing that. You have options here, like you can say that all of this information on the left is for a certain triangle, and then all the information on the right is for a certain triangle, and then the top part is like a certain side, and then this bottom part is a certain side.
Okay.
Or and this is very important here, you could make the top part the triangle, the bottom part the same triangle, the first triangle, second triangle, and then vertically that could be like the corresponding sides, vertically the corresponding sides. And maybe that wasn't very clear now that I said that out loud, but the point is you get a choice. You just have to do sort of the same orientation for each one.
Okay.
Try and do a better job here of explaining for number 7.
Okay.
I realize this format really isn't great for what we're trying to do, but for this class, this particular class. Okay. So one of the things like I want you to notice right away is that S corresponds to J because of this single line and then this single line here. And that
Yeah.
Z corresponds to F. Okay.
Okay.
Now it may not matter because they only give you 1, 2, 3, 4 pieces of information. So it's not like they like, what if they told you this over here was, I don't know, 16? Then you could have problems because you have to know what to do with it. I suggested putting the thing you're trying to find in the top left. So I'm just going to pick this x plus 9. So this x plus 9 corresponds to the 4x plus 3. Do you agree with that?
Yes.
Now you have a choice. You either put the 4x plus 3 here, or you put the 4x plus 3 over here on the top right. Where do you want to put it? And there's no wrong answers, just whatever you think you would do.
Under the...
Okay. You'd put it over here. So basically you're saying, okay, this top part has to come from the thing on the right. Bottom part has to come from the thing on the left.
Okay.
So on the right, I've got 15.
Yes.
So the 20 has to go down here because the 20 is for the one, it's a quadrilateral, and this is another quadrilateral. So and that's how you figure out where to put the numbers. Like once you make a choice, then the other ones have to correspond to it.
Mm-hmm.
So try solving this on your own. I'll give you 60 seconds. You're going to cross multiply again like we did in the first couple of questions. How are you doing on solving this?
I got x equals 3.375.
We got the same thing. Great. Okay. You'll definitely get some sort of problem like that on that quiz. That's kind of a standard thing. Either the triangle or another type of polygon.
Wait, so if we did for number 6, if we did x, like, you know how you said that there was like an option to set it up, like
Yeah. Why don't we set up again? I'm just going to copy the picture down.
So could you do x over 9 equals 10 over 4?
Yes. So you could say I'm going to put x up here, and I really want the same. I want this to be from the same triangle. So that's where you say, oh, it's 9. So what corresponds to the x? Well, it must be that 10. And then the 9 down here means I got to put 4 here, and you end up getting the same thing.
Okay. Okay, that makes sense.
Yeah, you end up getting the same thing. Okay, let's move to number 8. All right, so this is two similar polygons, and it's being intentionally vague. Like it could be a square, it could be a five-sided thingy. We don't know, but it says they have a scale factor of 3 to 5.
Mm-hmm.
The perimeter of the larger polygon is 120 feet. Find the perimeter of the smaller polygon. Okay, so let's there might be a formula in the lesson here. Um, for learning, I think it's worth just doing. We'll just make something up here. So let's say this is 1 and this is 2, and that's terrible because I can use the grid here. Um, sorry, let me do this differently. 3 and 6. Okay, so let's say uh, the smaller. This is gonna be the smaller one. It's 3 to 6. That means
Mm-hmm.
that this one is like 5 here. Actually, let me change the number here. Sorry. Doing a terrible job here tonight. I apologize. 3 and 3. Okay. And so this is 5 and 5.
And 5.
Okay. So do you see that they have a scale factor of 3 to 5?
Yes.
So what's the perimeter of this bottom one? Or, I'm sorry, the one on the left here. 12. And what's the one on the right?
Oh yeah, 20.
20. What's the ratio? What's 20 divided by 12?
Um.
What does that simplify to? It's very important. Give it to me as a fraction, please. Like 4 goes into both. Do you see that it becomes 5 to 3?
Yeah.
Okay. So the sides are 5 to 3 and the perimeter is 5 to 3. So that's really important that you know that, or that's clear. So that means you can just set up a proportion. 5/3 equals. Does the 5 correspond to the bigger one or the smaller one?
The bigger one.
Bigger one. It gives you the perimeter of the bigger one. So X is down here. So X is the smaller perimeter. 120 is the larger perimeter. 5 is the larger scale factor. 3 is the smaller scale factor. 5 times X equals 3 times 120. So we have 5X equals 360.
600.
So X equals 60, 70, it looks 72. So the offshoot of this is that if you have perimeter 2 over perimeter 1 equals side 2 over side 1. 7.2 probably had something like that in there.
Mm-hmm.
All right, let's move to 9. Do you recall from class what is required for similar triangles? There's congruent triangles, but then there's also similar triangles. There's letters that they often give you.
I don't remember.
Okay, so there's angle, 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 and an example of that would be like a triangle, a triangle like this, and then a triangle like this, because they're basically centered the same. And the other one is angle, side angle, and that one is generally something like, here's my triangle, and then here's another triangle, like that. They share a point. So nine is the second type. It's an angle. I'm sorry, it's not angle side angle. It's side angle side. Side angle side. So the angle is right here. So this ZRQ and this ZXY, they share the angle. Okay, and you can actually prove that this side is proportional to this long side, but we don't have that information. So how else can we do it? Well, we have to go back to the angle. This angle right here that I've drawn the double line for, it's the same as this angle right here because these are parallel lines and it's cut by a transversal. Do you remember that from earlier in the class? These are called corresponding angles. And then same thing down here, 1, 2, 3. That's the same as 1, 2, 3. They're corresponding angles. So these angles are congruent, these angles are congruent, and this angle is congruent to itself. It's reflexive. So you get AAA for that.
Okay.
So it does say to write a similarity statement. So we can do that. We would say that triangle Z to R to Q is similar to triangle Z to X to Y.
Z, X, Y. Okay.
And there's other ones you can write, but this is the most, that's one of the ones you would say. All right, number 10. Number 10. Okay, number 10. I want you to find the third angle in each of these triangles. You know that the sum of the interior angles must add up to 180.
So C equals 16. Okay, so in triangle ABC, the missing angle is 66 degrees.
Okay.
And then for HGF, it's 70 degrees.
Okay. So are the angles all the same in both of them?
No.
So you can say no to AAA. And the only other possible one is side angle side, but they don't share a point either. So no to that as well. So these are not similar.
Okay.
All right, let's move to 11. Move to 11 here. So the instructions for 11 say identify the similar triangles. So they're telling you like these are similar. So you want to look for things like okay, the 87 goes with the 87, the 46 goes with the 46, and that gives you kind of an orientation for this. So like that means that S goes with K and R goes with J, and then T
And
goes with yeah. Okay, so that's nice. they want you to find each measure. I don't know if they want you to find like this right here, this angle L and that angle T. It's not identified as, so I'm going to say no. They want you to find X though. So X, and let's put the 3 here. I think that's what you've kind of been. Um, so X is S to R. The way I've drawn it here, S to R is like K to J. So K to J is 16. 3 is like S to T, or maybe we can go T to S. So T to S. So that's like L to K. L to K is 12.
Wait, so X over 3 and then 16 over 12?
Yes.
Okay.
So when you solve that, you should get X equals 4. Yeah. All right, so 12 is a little bit more challenging, but let's see if we can do that here.
Okay.
Okay. So I often say it's this side right here to the whole side right here is it's side to side. This thing right here, F to B, is nothing. F to B is nothing if you get that. You always have to add it to something else.
Mm-hmm.
So in this case, like this 6 right here, this has no meaning.
Okay.
The 6, but if you add 9 plus 6, that gives you the whole side. That does have meaning. So another thing you could do is if you actually made these separately, you would see exactly what I'm talking about. This is 9 and this is X. This is 9 plus 6 and this is 18.
Okay.
So see if you can write the proportion based on that.
Okay, so X equals 10.8.
Say that one more time.
X equals 10.8.
10.8. Sounds right. Okay. Any questions on that?
No, I think I'm good.
Okay. Now I'm going to skip 13. I have no idea what that's really referring to, and I would just ask your instructor. You're not going to see that on a quiz unless they pull exactly this question. Okay, 14. 14. So they want you to find X and Y. Okay, so this dashed line and this dashed line means that these are equal. They're the same. So that means you can set them equal to each other. It's 3x minus 9 equals 4x minus 22. And you can solve for x.
Okay.
Where I am now not sure of, I really wish I had your textbook here, is what can we do with this information on the left? So see if you can find something in 7-4. I assume you have your book in front of you?
I do.
Nearby? Okay. I'm going to do some looking on my end. I cannot tell you if the, angles are the same.
In all the examples I see, it is a proportion.
Okay. Well, having the value of x helps us get the value 3x minus 9 is 24. And then, sorry, 22. 24? 20. 33 minus 9 is 24, isn't it? What am I not seeing here? 3 times 11 minus 9 is 33 minus 9, that's 24. 4 times 11 minus 22 is 44 minus 22, which is 22. What am I not getting here? Subtract, add, x is 11. Really struggling here to see why this is not right. Oh, because x is 13. That's why. Okay. Okay, so 3 times 13 minus 9 is 30. 4 times 13, 52, that's 30. Okay, so these are both 30. Now, what did they set up as the proportion? Do they say like 30 over 30 equals 17 plus 5y over 13 plus 6y? I'm guessing.
Yeah.
Okay. Now this, I haven't mentioned this, but you could simplify this on the left, and I really, this would be a good time to do that. It becomes 1 over 1 equals 17 plus 5y over 13 plus 6y. By simplifying the fraction, when you cross multiply, it's much more straightforward. It just becomes 13 plus 6y equals 17 plus 5y. Subtract 5y over here, you get y equals 4. And actually, you just have to find x and y. You don't have to do anything more than that.
So y is 4 and x is 30?
Yeah. No. X is 13.
Oh, okay.
X is 13. I made a mistake adding. Apologies.
Okay.
Okay, so let's try. Got 15 here. Maybe we'll go back and look at 12 if you want after this. Okay, so again, kind of you got the situation where okay, these are equal. So you can set 12 minus 2x equal to 8x minus 18.
Okay.
Now I think you can just set 7y equal to 5y plus 16. The problem is I don't have a good explanation for that. And it does come out of 7, 4. You do often just set stuff equal.
Y equals 8?
Yeah. I'm sorry I can't give you more explanation on that. Got some time left. What else would you like to work on today?
Is it possible if we could go back to number 13?
And I really don't. I'm looking at it again. The letter was 1/12 the height of the letter. Thickness of the major stroke.
When I go back to the lesson, like where it's from, it just says like proportions.
Yeah.
This is very strange.
Yeah. Explain why the bar through the middle of A is half the length of the space between the outside bottom corners of the sides of the letter. I'm going to check another. I've got access to these solutions, I think. So let me try to see if I can give you some explanation.
Okay.
You might want to look at the back of the book. So I found something here. It's not. I'll just snip it in. It's like it's pretty complicated. Okay, so it says the bar connects the midpoints of each leg of the letter and is parallel to the base. This is true because the bar is along the diameter of the inscribed circle. So they're saying that this bar here is along a diameter, which is true. Because of a midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. Okay. That's what it says. And then the other one is a proportion. We probably could have done that. You just said 1/12 equals x over 3. Yeah. Therefore, the length of the bar is 1/2 the length of the base. It's saying, okay, there's a big triangle here.
Mm-hmm.
They're saying that this right here, if you move it over, it would be. Let's try to copy that. This base here would be going right there, and this is exactly half.
Mm-hmm.
It's supposed to be half of these. Those would all be the same.
Okay.
All right, that does conclude the lesson today. I'll send you the notes and the screen recording here shortly, the next probably 20 minutes or less.
Okay, thank you so much.
Thanks for scheduling. I'll talk to you later.
Bye.